Hello. I know that in the beginning of my YouTube channel I had some science videos up, and then I got caught up in making quote-unquote fitness videos. I mean, well, there are a lot of fitness videos, a lot of exercise videos. And I realized, you know what, I have not posted a science video in the longest time. And to be honest, science videos, I would probably love to make them more than fitness videos because I love science. I love the immune system. I love cancer biology, like studying cancer biology. I don't love cancer, it's horrible, but I love studying cancer biology. And I really like cells. And so I was like, you know what? I need to make another science video. So sit back, relax, and get ready to hear about some research that I was privileged to do with Dr. Melissa Labonte Wilson and my partner, Ethan. We did some pretty cool research, and I'm going to share that with you now. So get ready to have your mind blown to hear about how chemotherapy works. All right, poster. So, title of our research: Assessment of the Mechanistic Chemotherapeutic Resistance in Thymidylate Synthase (TS) Targeted Treatments of Colorectal Cancer. So let's learn about how these inhibitors of thymidylate synthase work and why thymidylate synthase is important for cancer cells. I'm really trying hard to zoom in on here. So this is our introduction. So thymidylate synthase is a key enzyme to DNA replication in cells. So yeah. What it does is it takes a substrate called DUMP, diverts that to DTMP. Now the DTMP, this right here, that is subsequently phosphorylated to create thymine. Thymine is one of the nucleotides common in DNA. You'll recognize that if you've taken a basic biology course. There's G, A, C, T. Guanine, adenine, thymine, cytosine. Those make up DNA. So your cell has to get these nucleotides. Somehow it builds them. This enzyme, thymidylate synthase, helps make thymine. It's called a non-redundant enzyme, so thymidylate synthase is the only enzyme that can convert the uracil precursors to the thymine precursors. So what these drugs do, these thymidylate synthase inhibitor drugs, they inhibit thymidylate synthase. So what happens in cancer cells, you have to remember, cancer cells are replicating super fast. They've gone crazy, essentially. They're crazy cells. And they're replicating. So they're using a lot of nucleotides. So if you inhibit thymidylate synthase, you're inhibiting the enzyme that's making thymine, and you're building up uracil precursors. Uracil is only supposed to be in what? If you've taken basic biology, you should, again, know this. It's the U nucleotide. It's only found in RNA, or it should be only found in RNA. So if you have a whole bunch of uracil building up in the cell that's trying to replicate its DNA, eventually it will start to incorporate that uracil into the DNA as the cells replicate. And the cell will go, whoa, 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 we're not supposed to have uracil in the DNA, something's wrong, and it'll kill itself. Apoptosis, or apoptosis, if you say it how the Greek pronounces it, but anyway. Apoptosis, that is programmed cell death. The cell goes, oh no, something's wrong, uracil's in the DNA, we're killing ourselves because there's something wrong here. So that's how you try to kill cancer cells. Why are some people resistant to this? Well, there's another enzyme found in your cells called DUTPase. DUTPase breaks down uracil back into this DUMP. So once the drugs that inhibit thymidylate synthase wear off, once those drugs wear off, if you have if you have a lot of DUTPase inside the cell, it's going to counteract the inhibition of this enzyme. And again, that's because this is breaking down uracil into this DUMP. As soon as the drug that we're using to inhibit the thymidylate synthase wears off, DUMP is going to hop right back into thymidylate synthase and make thymine again, and your cancer cells are going to be fine. They're going to have their thymine, they're going to keep replicating with thymine. The cell won't go, whoa, we need to commit apoptosis, because there won't even be any uracil in there. So that's why having this buildup of DUTPAs is not good for people that are being treated with agents that are supposed to inhibit the thymidylate synthase. So what we were researching is we were researching small molecule inhibitors of DUTPAs. They're called this for the sake of secrecy. These are cell lines that we were using. These are cancer cell lines. So what we did is we tested it. This is our control. We did not test, we didn't treat the cancer cells with any medications in this line right here. Here, we only treated it with an inhibitor of DUTPAs. Here, we only treated these cells with FUDR, that is a medication that inhibits the thymidylate synthase. And then here, we can bind these two agents and treated the cancer cells here. You can see the small molecule inhibitor worked. It combined efforts with this medication to really wipe out the cancer cells. So this research project was actually a success, which was really, really exciting. It was a very exciting project. Right here, you can go ahead and read this. The project evaluated a novel small molecule DUTPase inhibitor and tested them on multiple colon cancer cell lines to determine their effectiveness on the inhibition of cell growth. We tested the inhibitors for cytotoxic effects, both as a single agent and in combination with FUDR, which is the bioavailable form of the principal CRC colorectal cancer chemotherapeutic drug 5-FU. 5-FU, 5-fluorouracil, is the name of the inhibitor of the thymidylate synthase again. So let's go ahead and zoom in here just so we can see what happens whenever we use that medication. So you take the medication, it gets metabolized in your liver, 5-FU goes into the cells, 5-FU comes down and inhibits thymidylate synthase, bam, DNA damage, because, again, we have that buildup of uracil, which the cells go to misincorporate into the DNA because it's replicating quickly. So I'm going to go ahead and zoom out. Here were our results. If you want to go ahead and look at them, I will pause for a second so you can look at the results. So this is kind of like the timeline of the project. 1, 0, 2, 3, 4. Those are just different forms of the small molecule inhibitor for DUTPAs. Enantiomer, if you've taken organic chemistry, you know what an enantiomer is. DL, what it is, what an enantiomer is. For those of you who haven't taken organic chemistry, I have two hands, right? These hands are identical, except for the way that they're formed in space. They're non-imposable. So here, my palms are facing each other, my thumbs are here. If I have it so my palms aren't facing each other, my thumbs aren't going to line up. So it's the same thing. I have two hands, they both have 5 fingers, they both have, let's just pretend they have, the same lines, everything. But the way that they're arranged in space is opposite of each other. That's what an enantiomer is. So you can have a medication, and that medication will have the same chemical structure, the same chemicals inside of it, but they're different in space. DNL, what they're called. Anyway, so we actually, Dr. Wilson and Ethan, one summer figured out the reason why. I forget which one they were working on, but they figured out that there was enantiomers in this mix, and that if they separated them out, and they found the more active enantiomer, then that one was more effective with the treatment. So that's where we ended up getting this. So yep, I already explained that, and we tested. This is how we tested to make sure that the DUTPase drug was working how we thought. So we, in these colon cancer cell lines, we added both the thymidylate synthase inhibitor and we added the DUTPase inhibitor. And again, we should see cell death because of all of that we just learned. But if we add thymine into the cell, into the mixture, we give the cells thymine back, they shouldn't die, right? They shouldn't die because we're giving them thymine. Because again, remember, we're trying to deplete the cell mixture of thymine using the 5-FU and the DUTPase inhibitor. We're trying to get rid of the thymine so they incorporate uracil into the DNA and die. If we add thymine back, they should have thymine and not have to incorporate uracil into their DNA. So we tested that, we added thymine, it worked, which meant the pathway that we thought we were targeting, we were actually targeting, because once we added thymine back into the mixture, the cells didn't die. So, here's our conclusion. The results demonstrate synergistic capabilities of DUTPase small molecule inhibitors when combined with TS-targeted, remember that's thymidylate synthase, targeted chemotherapies in colon cancer cell lines. Though thymidylate synthase-directed drugs such as FUDR and 5-FU are effective alone, remember we said they are effective in colon cancer patients, just some people overexpress DUTPase. Simultaneous DUTPase inhibition has been proven to overcome patient resistance to the fluoropyrimidine treatment, that's just the 5-FU thymidylate synthase treatment, and increase overall efficacy. This proves further evidence for DUTPase as a valid chemotherapeutic drug. Further studies need to be conducted for understanding of DUTPase inhibition in vivo, as well as validation of apoptotic induction. So what we now need to do with this drug is see how DUTPase inhibition in humans work. Well, we wouldn't go directly to humans, you'd go to mice next. See how it works inside of an animal with cancer. See if it helps reduce the tumors and reduce the amount of cancer in the animal. And then also make sure that apoptosis is being induced by these drugs. Again, we're assuming that it is, because that makes sense from what we know about cancer, but in order to validate it, we need to run more studies to see if apoptotic markers are appearing to make sure that apoptosis is actually occurring. And that is the research. It's pretty cool. It was very fun. Shout out to Dr. Wilson and Ethan. It was a lot of fun working with them. I highly enjoyed cancer research. I really, really thought it was fascinating. I loved learning about it. I loved our journal club. We would meet with Dr. Wilson's other research partners. We would get to meet with them, and we would get to present, different articles on cancer research, and learned a lot. I learned a lot from my presentation. And then you learn a lot listening to other people talk about cancer research that they'd been researching. And it was a lot of fun. It's a lot of fun. It's a lot of fun getting to do things with people that have similar interests and can understand what you're saying. Whenever you're talking about thymidylate synthase, they go, oh yeah, I know what thymidylate synthase is, instead of, most people, and they're like, what is thymidylate synthase? But yeah, it's a lot of fun. I miss it. I actually hope to be a gynecologic oncologist one day, so I'll get to do more cancer research, hopefully, one day, and work with women, yes. That's the goal. Working towards the dream, guys. Always working towards the dream. Always working towards the dream.